I'm an assistant professor at VirginiaTech. I direct what I like to call the Maternal Influence on Neurodevelopment Lab. We focus primarily on infants and how moms impact brain development, specifically during infancy. And I do have to highlight that I have a faculty position in the Human Development and Family Science Department at VirginiaTech, and this is important because it really does shape how I think about things. We're a very human-centered discipline, so I'm going to talk today about kind of navigating the balance between our scientific goals and the realities of working with babies and their families. And I hope, based on some of the questions that I've heard, I hope to address some of those about the practicalities that you just have to deal with, right? Because we have so many questions that we want to answer, but if families won't come in, it doesn't matter. So, all right, I start every talk with gratitude because I don't know what I've done to deserve the team that I have, but they are absolutely amazing. These are a couple pictures of us enjoying the gorgeousness that is Southwest Virginia. If you ever get a chance to come and visit, please come and visit because it is a beautiful part of the United States and underappreciated internationally, I think, part of the United States. I'm not going to name names because there are too many, but just know that there's no way that I could do a fraction of what we do without every single person listed here. Certainly not without our funders. And then last, but absolutely the keystone to everything we do are our families, right? Because again, if we had unlimited funds, if we had all of the cool tech in the world, it wouldn't matter if they wouldn't come in, right? All right, so to give you just a sense of where I'm going in this talk, because I know my title is a little weird and kind of vague, so it was maybe not as clear where I was headed, but I'm going to talk a little bit and very briefly about longitudinal studies in a much more kind of reductionist way than what Terry just spoke about. I'm going to again talk about some of the practicalities of longitudinal studies because I feel like based on questions that's really of interest to this group specifically. And then I'm going to use human milk as an example of a driver of neurodevelopment that I'm particularly interested in and how I've tried to think of, again, balancing some of the practicalities as well as what we know about human milk and brain development to design studies that we can actually start to answer some of those questions. All right, so at the end of the day, so when I die, I really hope that all my work has led to some provision of empirical evidence for best practices to optimize infant neurodevelopment so that parents can do what they're already trying to do, which is raise happy, healthy kids. So this is definitely the human development part of me coming out because when you work with a baby, you aren't just working with a baby, right? I don't think I have to say that to this audience specifically. You're working with their families. And then if you start to think more about kind of the nested structures that families find themselves in, if ultimately we want to optimize neurodevelopment, then we need to be thinking about lots of different layers, right? And lots of different potential ways that we can do it. And so this is where I have to say I don't study clinical populations, so I study typically developing, as well as, depending on how you define typicality, kids in adverse situations, which I would argue are not necessarily atypical situations. So again, that's kind of semantics at this point. But just knowing how is the brain developing, right? So whether it's in adversity or not. And this is where the piece of needing longitudinal data, specifically imaging, really becomes important. So this is a infographic that you can grab off the web from the United States Centers for Disease Control and Prevention. It's handed out to lots of parents when they come in for their postnatal visits. And the idea here is they want to kind of reassure parents that there is a pattern of behavioral milestones that children should pass through, but there's a lot of variability. And one of the things that we think is underlying this variability is our differences in brain structure and function, potentially, right? So really, but what we want to get at isn't necessarily what does the average 6-month-old look like or what does the average 12-month-old look like, but what we want to know is how this gorgeous baby, who might be mine, went from this, as my husband liked to call her, a squishy paperweight or angry potato, depending on the time of day, all the way to this gorgeous then 4-year-old. She's now a terrible 10-year-old, so no pictures of that. But what we really want to understand is how she's changed across time. And to me, that's just kind of built into this idea of development, right? If you just look at a group of 3-month-olds, You are studying a developing individual, but in my mind, you're not studying development because we need to know how that child is going to change across time. That is the definition of development in my mind. And so that requires these really beautiful longitudinal images, as are shown here. So this is a one individual, a little girl that I scanned as a postdoc at the University of Minnesota. And I don't think you need any special neuroradiological training to recognize how different she looked at 3 months compared to 24 months. And so that's a massive amount of change, just structurally. Again, you don't need fancy things. I know, Dr. Edwards is right on where, this isn't the be-all, end-all, but it really does emphasize this point that there's a lot of change happening very quickly. And so what that necessitates is longitudinal data, relatively high frequency, and lots of potentially multimodality, depending on your questions, right? But to get these data, there are a lot of practical considerations that you just have to take into account. Otherwise, you'll never get them, right? So I'm going to start with talking a little bit about recruitment. So I'm really glad that somebody asked the question about recruitment because it is central to everything we do as researchers. So I have colleagues that work with clinical populations, and I'm not saying in any way that it's easy to recruit a clinical population, but oftentimes, especially for infants, parents are pretty motivated, right, because they want to help their children. It's a little harder to get parents on, well, not once you talk to them, you can get them on board, but how do you make that initial connection? And so my team works really, really hard to make connections so that we can do robust, impactful, and longitudinal science. So that requires representative samples. So as Terry was saying with ABCD, it is key that that group is representative of the people that we would like to learn more about, which is all people, right? So we want people from all walks of life. That's not always easy, especially depending on where you live. So this is a map, a partial map of the United States. So to orient folks, New York City would be somewhere over here. So this is the eastern coast. Roanoke is where my lab is, right here, and this red and white section is called Appalachia. I have no idea how well known Appalachia is in Europe. It's fairly well known in the United States, but not really in a positive light. So if anybody has seen the movie Deliverance, if you haven't, don't, because it's a terrible movie, has Burt Reynolds in it. But anyway, it really shines this terrible, terrible light on Appalachia, which is actually a really gorgeous part. I mean, I showed you pictures at the beginning of, yes, my lab enjoying the outdoors, but culturally, they're very focused on family and community, and they find their strength in that, but that's not how they're portrayed. What that does then, when we go in as university professors and doctors, they don't want to talk to us right away, because they feel like we are looking down on them. So my lab works very, very hard to really build trust within the community, and I'll talk a little bit more about that in just a second. Because when we start to build that trust, then we can get honest responses, right? Because parents will tell you what they think you want to hear. And that's not good science, right? We can't do that. And this isn't just low SES families or low resourced families. I often have found that it's much harder to get affluent families to tell you things and be honest because they think you want to hear that they're perfect. 100% not true, right? We want to hear about them in everything that they are. And so I often describe studies because they'll ask, what are you looking for, right? How are you looking, what kind of terrible things are you trying to find in my child? And we're not trying to find anything terrible. We want them to share with us what typical development looks like within that specific family context. And then the last thing, and Terry talked a little bit about this, they have to want to come back. If they don't want to come back, they won't. And when you're doing longitudinal work, particularly early in life, when they have a lot going on, right? They may have a newborn, maybe they're potty training, maybe they have a new baby, and you're following the younger sibling, or older sibling up, rather. There's a lot happening, and you need to be the ones that make it easy for them. So some of the ways that we do that is we meet participants where they are, and I mean physically. So we will go to participants whenever we can. We are allowed at VirginiaTech, this is not always true everywhere, to transport participants. So we will go and drive and pick them up and drive them back down so that they can be scanned or do whatever assessments they need. We provide transportation, food, lodging, everything. Because what they're doing, especially in the context of infant MRI, because we do primarily evening scans when they sleep best, it's a big ask to say, hey, please drive in. We're going to take a few hours to scan your baby. Peace out. We don't do that. That's not how we work. We say, hey, there's a hotel right next door. You're welcome to stay. We also, and this is a really key point, offer this to everyone. It doesn't matter how much money they make. It doesn't matter where they live. Because if you don't offer it to everyone, then you're going to potentially be introducing some bias, right? You may have families that need it, that are embarrassed or proud, and they don't want your help, right? And so we don't frame it as help. This isn't help. This is exactly what we do for every single participant that comes in, and that is true. We do that for everyone. We show them how much they mean to us, and so they do get compensated for their time, but then we also do kind of extra things. My lab is a little bit extra, my family is a little bit extra, so everybody gets a gift bag when they enroll. My mom has knit blankets for all of our babies. So we have little closets full of knit blankets that my mom and now some of her friends, and it's a whole thing now. But what it really does show is that we're a family here. They're now a part of something bigger than themselves. And it really goes a long way to build that trust. We do consistent and sustainable community engagement. So we don't just go out into the community when we're recruiting. This is key, because why would you ever expect somebody to want to be involved in something if the only time you go and talk to them is when you need something? That doesn't make sense. So we're constantly doing, going out into the community and doing presentations about brain development. We host blood drives. We do whatever the community needs. We're there for them. I also work really hard to hire community members to focus on recruitment and retention. People are more comfortable coming in if they feel represented on the team. Because again, it's not us studying you, it's us. We are part of the same entity. And I just happen to have a really nerdy interest in the brain. You, as a dental assistant, have expertise in cleaning teeth. Very necessary, right? There's no hierarchy. There's nothing like that. We make service a priority. This again, I think, and I sound like I'm trying to sell you Virginia Tech. I'm not. But the motto for Virginia Tech is ut prosim, which is Latin for that I may serve. And it really is kind of baked into the culture at Virginia Tech. So it's really, really easy for us to go out into the community. We get hours to go out into the community and do community service. And what ends up happening then is everybody does love a Virginia Tech Hokie. The Hokie bird is shown here. That's our mascot. It is not a turkey. Please do not gobble. I will get kicked out. No, I won't get kicked out. But the point is, we have a culture that really does revolve around this idea of service. And when you're doing human participant research, that's really key, right? We're able to kind of build on this brand, so to speak. And then the last and not least is we ask the community about our studies before we start. So we do things that are called community engagement studios, which are kind of like focus groups. And we will kind of say, hey, this is the question we're answering. This is how we think we should answer that question. What do you think? And oftentimes you get the best suggestions for just the logistics of a study, because we're the scientific experts, right? I'm not an expert on what it's like to be a part of every single family that we want to represent. And so what we do is we bring them in and we actually just ask. It's pretty easy. And then this all feeds, again, back into that building trust and a culture around research participation. Okay, so I'm going to jump into a little bit of data. So using all of that information from tech, this is not any work that I did at Virginia Tech. This is work I did at the University of Minnesota as a postdoc, where I participated in something called the Baby Connectome Project. The goal of this project was to look at brain and behavioral development across the first 5 years of life. This was a prospectively recruited cohort using an accelerated longitudinal design, which is shown here. And so if you look, each one of these horizontal lines is an individual child, and then each point is where we got, in this plot, a T1, a T2, and a set of resting state data. So this is just to show you kind of the spread of our data, and I'll show you it in a different way in just a moment. Again, we had 2 sites, so Minnesota and then the University of North Carolina at Chapel Hill. The goal was to recruit 285 longitudinal families, and then 215 cross-sectional. We got close, not quite. We did sleep scans on all of the kids younger than 36 months, and then we attempted, keyword attempted, awake scans for the older toddlers. We did usually try to get them to sleep first, and if that failed, then we would scan them awake. My older daughter, Nellie, is one of those failed sleep scans. So here's another representation of those data. And so again, this is just to show you the proportion of sleep scans at each age versus wake scans, which are shown in red. And so we have this spike at 24 months because we had a follow-up when most of the kids came back in for a behavioral follow-up and a scan. Okay. So this is the protocol. I'm not going to belabor this. If you're interested, this is all published in a 2019 paper, but what I do want you to take away from this is we had a T1, a T2, and one set of resting state. That's what we defined as a successful scan. So if they woke up after that, then we said, thank you, you're awesome for coming in, we're all done. If they didn't get through that one set of resting state and we couldn't get the baby back to sleep, we would invite them back for a second attempt. But if people have questions about Connect-On, let me know. This is my younger daughter and her beautiful brain at 10 weeks. All right, so I want to talk a little bit about, and this is just a tiny, tiny bit. I have whole presentations just on this, but again, it seemed of interest to the group yesterday, so I wanted to cover it even scarcely. So for pre-scan prep, it's a little different than what was talked about yesterday, because yesterday you were talking about preparing the individual that's going into the scanner. They're babies. We're going to get them to sleep. They aren't going to know what's happening. So who do we need to prep? We need to prep their parents way more than we do the baby. The baby will sleep, right? And so we do a lot of that by having conversations with them. Where did they sleep? How did they sleep? What did they like? What did they not like? Because all of those things factor into how we approach starting the scan. We try to meet the family in person before, if at all possible. So I was talking with Marissa earlier about this, because as soon as a family walks in, I don't want to say sizing them up, but you're observing what that baby likes, what they don't like. Is mom or dad or grandma, whoever brought them in, are they nervous? And if they are, you have to talk to them about what is potentially causing that anxiety. Because if you have an anxious family, they're not gonna stay. They're gonna feel terrible. As soon as that baby starts to wake up, they're like, nope, I'm out. And that's fine. They get to decide that. That's also key for our for longitudinal scanning, is you always make sure that they feel like they are in control, because they are. That's not some sort of false sense of security. That's no, you get to decide, and if you're done, you're done. No problem. But the key is making them not want to be done, which is actually not that hard. We sometimes send home practice materials. I often think it just adds to stress, so we don't usually send a ton. And we instruct them not to change baby's schedule. This is dependent on the child's age. And again, if people have specific questions, I'm happy to talk about them. And then we do walk them through the scanning procedure very stepwise. And we do have a video of our specific center. It shows where they will park, where the elevators are, and exactly what will happen while they're there. So when do you put the earplugs in? What kind of earplugs? Is there ionizing radiation? All of those kinds of questions are addressed. And this is just a picture of a corner of our prep space. It's actually a really terrible picture. I need to get a better one. But we have a sofa, and we're getting a TV, and we have an MR-safe crib all in that room. Because the idea is we want them to be comfortable. We want them to stay there, potentially for hours, right? And if it's an uncomfortable space, they're not going to want to stay. It's also really nice because it's pretty private, so that if they want to hang out with us in the control room, they are welcome to, but they often want to hang out here by themselves. All right, so here's a picture of the setup, and actually the picture on the right is the Minnesota setup, but the VirginiaTech setup is very similar. So we just have, some padding to lift the baby up, lots of padding to pad their head in. We have a weighted blanket for tummy sleepers, because as soon as they go to sleep, they'll try to roll, and you just want to have some nice pressure on them so they don't. We cover all sources of light with really fancy light-blocking curtains I bought at Walmart and then cut up and suction cup to the front. And then we have an MR-safe crib, which actually is pretty fancy. So this is one that I helped design when I was at Minnesota. And it's pretty simple. It just straps on to the bed, and then there are little tiny feet that sit in the grooves on the bed, so that when they're falling asleep, if they roll onto the side, they won't fall. And this way they can fall asleep completely untouched, because a lot of kids, especially when parents have worked really hard for sleep training, they're not going to fall asleep in somebody's arms. And so they're able to do that safely. And then we also play scanner sounds in the room, even when the scanner is off. So the idea there is that between sequences, when there's always that pause, there is as little contrast and sound as possible. Okay. So that's where I'm going to end with this part, but I'm happy to answer lots of questions after. I wanted to quickly go through, because I often get the question, well, how does all of this work? Are you actually getting data? And so these are success rates from the Baby Connectome project. So again, this is all Minnesota data. So if you look across all of the ages that we scanned, so from 1 month all the way to 60 months, and these are all sleep scans, these are only sleep scans, we had about an 83.5% success rate. So each of these horizontal bars is the proportion of successful scans, then the number is the actual number of successful scans. So this is our success rate for just getting a usable T1, because we always started with a T1. Then we were down to about 79% for a T1 and a T2. We get lower to about 75% with a T1 and T2 in that first set of resting state. And then if they continue to sleep, we continue to collect some diffusion, and we're down to about 54% at that point. So take this for what you will, but if you're starting to scan, I think these are relatively comparable for the ages. Younger kids are usually a little easier, so you should be up in the 90%-ish range for those kiddos. Okay, so now I want to talk about the kind of exemplar driver of neurodevelopment. And the point I want to make is that a lot of the studies about maternal influence, at least when you're pairing it with MRI, are kind of convenient studies, right? We were already getting scans, so let's add behavior, or we're already in behavior, and then my office is next door to somebody who does this brilliant MRI, so let's do them together, right? But we haven't necessarily taken the time to think carefully about timing. So these are pictures of mammalian mothers. I don't think that fathers are not important. Please don't take that away from this. But just biologically speaking, particularly in mammals, moms have a really privileged place in development. And I also just like to show pictures of cute babies like platypuses. But in addition to kind of caring for their infants in these physical ways, they also provide the ideal source of nutrition early in life. And this is when the brain is changing really, really, really quickly. And so this figure just kind of emphasizes that. So the y-axis here is the brain weight. Each of these dots is this average infant. And then the x-axis here is postnatal age in months. And this is assuming a full-term baby, right? Lots of variables here. But if you just look at these vertical bars here, what they're trying to show is the proportion of total brain growth that's occurring during different lengths, durations of milk provision. So at birth, the brain is roughly 25-ish% of its adult weight. If you breastfeed for 6 months, and that's what's recommended by the World Health Organization, is 6 months of exclusive breastfeeding. You get another about 20-25% brain growth. If you reduce this duration by just 2 months, then you lose about 10% of brain growth that would have been occurring during milk provision, which is pretty striking, I think. And then if you continue up through 2 years, which this is where the World Health Organization suggests that lactating people stop providing milk, or at least try to make it to that point and continue on. There's been some empirical work that actually shows that about 2.5 is probably biologically the right age to stop providing milk. But anyway, point being, a lot of growth happens globally during this time period. I have a medical student who was interested in taking the Baby Connectome data and actually looking to see if there were regional impacts of breastfeeding duration. And so she did an analysis looking at amygdala volume specifically. And what she did is she used splines to look at the Baby Connectome data, and these are just the distribution of the data points that she used. And what she found is there isn't an overall difference in the shape of the trajectory, but what there is a difference right around 8 to 11-ish months. And this is interesting. This is based just on whether or not they were exclusively milk-fed versus non-exclusively. And so this could have been mostly milk, but some formula. So we were pretty strict with the exclusive milk feeding part, but not necessarily the formula part. And what's interesting anyway about this time is this is when a lot of the behaviors that you would associate with the adult function of the amygdala start to come online. So things like stranger danger and reactions to novelty and that kind of thing. So this is some evidence, albeit indirect, right, because this is just a correlation, that the duration of milk feeding is really important. So this might get at the duration and how that impacts it, but what I'm really interested in is the specific components of milk that are potentially impacting this. And so I focus a lot on milk, again, because of the timing, because it's being provided when the brain is changing very, very drastically. And there are lots of components in milk that have been shown to influence different parts of brain development. So we know that some aspects of milk have been related to MRI measures of white matter maturation. There's some evidence that some of the smaller molecules can actually increase neuronal firing rates, but this is all really indirect data, right? It's all really indirect evidence of this relationship. And the other thing that's really interesting, if you don't know this about milk, is that it's not static. It changes at different timescales. So this figure here is just showing the visual difference in quantity and color in milk at 3, 5, and 6 days postpartum. So this is colostrum. It's the really thick, sticky, sweet milk. And then at 25 days, this is the mature milk. And so this is what formula is trying to emulate. And when you think of milk, that's probably what you have in mind. But what this isn't showing is that actually during a feed, there are dynamic changes in composition as well. And I'm not going to touch on that right now because we're not there yet, not at all. But where we are at is being able to look at very specific components of milk and thinking about how they may be influencing some of those cellular processes that then can contribute to the overall brain development pictures that we can get using MRI. So my lab is interested in milk exosomes. They're these little tiny extracellular vesicles. They're about 30 to 200 nanometers in diameter. And they contain a lot of different factors that, again, have been shown independently to impact some of the cellular processes, but not necessarily in developing cells and not necessarily with any connection back to actual human beings. And so I'm a neuroscientist by training. And I actually started my academic career working in monkeys, not in humans. And so I always go back to, well, what's happening kind of at the cellular level? And so what we see at the cellular level during the provision of milk, which is about here, right? We see a lot of changes in oligodendrocyte production and maturation. And so this fits really well in a lot of the discussions that happened earlier. So Johan talking about oligodendrocyte precursor cells and how early in life they're changing. And so I wanted to design a study that would look at a very specific part, which are microRNAs that are packaged in these extracellular vesicles. I've just highlighted some of them here that we know are found in milk. And then they can impact a lot of these different pathways, like the transition from an oligodendrocyte precursor cell to a mature oligodendrocyte. So I designed a study, and again, the point here is that this was, from the very beginning, designed to look at how milk impacts later brain development. If you think about it, there's no real reason to think that the concentrations of something in milk that is such a dynamic fluid is going to be meaningfully correlated with structure or function at that point, right? That logically just doesn't make sense. So what we're doing now is front-loading with our milk samples and then looking at brain later. I'll also highlight that this is an infographic that we actually hand to parents. So when they come in, this explains exactly what they're going to do when and what their compensation will be, which is really important for the recruitment piece. And then these are just some milk exosomes that we've been able to isolate. All right, so we're working on the imaging data now, but I wanted to show some, they look awful because I just got them yesterday, but I was really excited. So I have a collaborator, we're using a piglet model, so these are cultured piglet day 2 oligodendrocytes. And so what this is showing is that our extracellular vesicles, which are shown here in green, are actually translocating to the nuclei of oligodendrocyte precursor cells. So we have a potential pathway that this may be impacting brain development. And then these really poorly labeled plots. So one, these are oligodendrocyte cultures of OPCs treated with our exosomes, and these are from human moms again. And we actually see an increase in the proportion of oligodendrocytes 48 hours post-treatment as compared to a control sample that they're getting, not our exosomes. So some really exciting work that, again, we have the milk from the moms, the imaging from those specific babies, and now we have some sort of in vitro screen to look at mechanism. And then I think this is almost my last slide. So this is another study that we have ongoing that is massive, and again, the point that I wanted to make is we are front-loading with all of our milk measures because milk, we believe, is laying the foundation for later structure and function, and then we're getting a lot of later structural and functional images and lots of behavior. All right, so if you don't take anything else away wake up now and remember these 3 things, that studying development really does mean longitudinal assessments, and that we really have to think very carefully about when we're trying to figure out what factors are shaping the brain. We need to think about context. So in my world, context is mom for infants. What we know about the biology, so things like when are oligodendrocyte precursor cells maturing, that kind of thing. And always keeping the ultimate goal of translation. So how can we actually use this information to improve the lives of actual people in mind? And then last, these successful longitudinal studies do require very thoughtful designs and a very human-centered approach. So it may seem minor to think that we need to have a bathroom near your scanner. We don't, and it's awful because we have to have a 3rd person there all the time to walk people to the restroom. But anyway, those are things that you might not have thought you'd ever have to consider, but they really are key to the success specifically of longitudinal studies. And so I have to do a quick plug. I know it's short notice, but if anybody has lots of travel time and you want to come to Santa Rosa, California, I encourage everybody to come to the Fetal, Infant, and Toddler Neuroimaging Group meeting in Santa Rosa. If you can't join us this year, please join us next year. It will be in Baltimore. We know the dates, but I don't have them on here, but it'll be right around the same time. And then with that, I'm sorry I'm over. But I do have to say we are hiring an MRI research associate. So that's a master's or PhD level person. So if you're interested in coming and helping with the Healthy Brain and Child Development study that Terry mentioned, please reach out because we have a lot of work to do on that project. And that's it.